Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting
most-
gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Hey! Oh, you gonna turn that off?
Yeah. Sorry about that. We don't usually get off to such a rocky start. This is embarrassing. Hey! What is this? That's me.
Yeah.
That is me, and you're erasing me.
Yeah?
Yeah, I'm fading away like that photograph in Back to the Future. So
Yeah.
That's realistically what would happen. You haven't seen that movie, have you?
No. Have you?
It's Back to the Future, Levi. You have to see Back to the Future.
Oh, I remember that line from the movie. That's a good line.
What line was that?
You have to see Back to the Future.
Where they say that in the movie Back to the Future?
Yeah, it seems like what they would do in that movie.
I could throttle you.
Throttler.
Throttler. I could throttle you. I could throttle you. Back to the Future is a classic.
Okay. Hey, Kuzi, are you here?
It's a classic.
It pleases me how easy it is to annoy you.
Well, you just know exactly how to annoy me.
Yeah. You kind of tell me.
Should I just keep it all in? And be dry and cerebral and calculating?
Ideally.
Ideally?
It's actually where calculus comes from.
From me? Being
Yeah.
Calculating?
Yeah.
Pretty sure that comes from Isaac Newton.
Alright. I have no idea if the chat's working or not, to be honest.
You wanna just quit? Oh, here they are. It says, yep. It says Taco Tuesday. Not Kuzi, says Taco Tuesday. Levi, this is super
Small.
zoomed out. Yeah.
Yeah, I don't know what to do about that because I just re-downloaded it.
Oh no. No, I don't want that.
Is it working?
Oh, no. I didn't want this. Hold on. There we go. I guess we're just gonna have to make do. Not Kuzi, what's up? And it's gone. Restream. Put on your where is it? Oh, it's down here now. Oh, interesting.
Is it working?
Well, it's now down here, so we could just read it there. But that's weird because we want to look up near the camera. All right, so I'm gonna.
Yes, Kuzi, we can. We'll do that now. You just
What? No, I wanted to go up on that screen.
drag it up to the top of the screen. Why do you keep moving it there?
I'm not. You do it. You do it.
What is going on in the Nerdish house?
Technical difficulties.
Technical difficulties. What's going on in your house?
There we go.
There you go.
Thanks, man.
Just make it full screen on that screen.
Oh, now I get it.
Whoa. When did these all get in? Okay, let's do a Kuzi question. I think it was just the last couple right here.
Who's?
Yeah.
All right.
You didn't make it big.
Am I gonna make it big?
Make it big.
Over here, like that.
Yeah, maybe.
Is that what you want?
Yeah, this looks like exponents, so let's do that. 8 to the something. Is that 8 to the 5/8?
8 to the 5/6.
8 to the 5/6. That's like the same thing, though.
I mean, if you're into that sort of thing.
I am.
Okay.
8 to the 5/6
Hey!
minus 8 to the
Hey!
1/2
I gotta stop doing that, man.
equals 8 to the m for
Yeah.
some value of m equals 8 to the m for some value of m. Well, that's interesting. You can't put these together, right? You're not multiplying them or dividing them. Yeah, we'll have to figure out a way to make that work better. I want to see the answers.
No, wait.
Oh, they're just numbers here.
Let's
Okay.
pull out 8 to the 1/2
So-
for both of these.
Do you want to do it?
Do you want to do it?
Not anymore. If we pull out 8 to the 1/2 from both of these, we will get division, or sorry, we get subtraction here. So we would get 8 to the 2/6, and we get -1 here. Yes?
Yeah.
Does that please you, Bird?
Yes. 8 to the 1.
And that equals 8 to the m.
Oh.
And the reason for this is when you're pulling out that 8 to the 1/2, you're going to have to you're subtracting 1/2 from this, because when you multiply back in, you'd be doing product rule, which you add the exponents for. So here, let's simplify that. So if 8 to the 1/2 times, ow,
You all right?
ow.
What happened?
It's fine, don't ask.
All right.
8 to the 1/3 minus 1.
Now we know that's the cube root of 8, which
And
is 2.
Yes. So now we have 8 to the 1/2, and then we have 2 minus 1 equals 8 to the m. So this just becomes 1, so it goes away, and now we have m equals 1/2, because it's just 8 to whatever power. Try to
Yay!
fix this.
That was a not Kuzi question.
Yes.
I guess this kind of is the Nerdish house, isn't it?
Yeah. You know what? Let me pull up the next one for you, and then while you do that, I will try to figure out the chat thing.
Okay. I'm gonna put my phone down. I'm gonna grab some markers.
Yeah.
I'm gonna get some cloths.
Divya?
Activia?
No.
Activia.
Alright, so we got a magnetic field. Ooh, what's this? Thank you for the sub, Kuz.
We got a sub?
Yeah, from Kuzi.
Oh shoot. Haven't done this in a while.
We haven't. Just stay right on my side of the screen, okay? Because there's not enough room for you, Bird.
Got it. Well done, not Kuzi! Well done!
Alright. So I'm going to erase this, and then Bird will be here soon
That's
to actually do this question.
All right. The strength of a magnetic field is measured in Teslas, like the car. 1 Tesla is equal to 1 Weber per square meter, as follows. 1 Tesla is equal to 1 Weber per meter squared. Divya is building a circuit for her physics class. Point P on one of her wires has a magnetic field strength of 6 times 10 to the 6th Webers per square megameter, where 1 megameter is equal to 10 to the 6th meters. Hold on a sec. Let's, oh, look at you. You figured it out. All right, get out of there. What is magnetic field strength in Teslas? All right, so we just have to convert this into the normal unit of Tesla, which is Webers per meter squared. Okay. So we can do this in terms of dimensional analysis. Right now we have 6 times 10 to the 6th Webers per megameter. And in order to convert this to Teslas, we have to get this to Webers per meter squared. Per megameter, right now it's a square megameter. 1 megameter squared. Get rid of this S then. So if you've taken chemistry, then you've done a lot of, it's called stoichiometry. But in general, it is dimensional analysis where you cancel out units in order to find what units you'd like. So we have to get rid of square megameters. We have to turn it into meters squared. And that is going to involve multiplying by some conversion fraction to do that. That will cancel out square megameters. So 1 megameter is equal to 10 to the 6th meters. So if that's the case, that doesn't mean that 1 megameter squared is equal to 10 to the 6th meters squared. Okay? For instance, we know that there are 3 feet in 1 yard. But if we have a square yard, that's not going to be the same thing as 3 square feet. Because a square yard is 3 feet by 3 feet, which is going to give us 9 feet squared. So we have to square the relationship in order to get what the area similarity would be. So we want megameters squared on the top. So first I'm just going to write our normal conversion. 1 megameter is equal to 10 to the 6th meters. But then I'm going to square what is on top and bottom in order to turn it into area, which is what we want. Okay? So the point of doing this is you get to cancel out megameters squared, because that is the unit that you no longer want. So let me use blue for this. That's gone. That's gone. And what we have down here, we still have 6 times 10 to the 6th Webers up top. But now we have 1 times 10 to the 6th squared. 10 to the 6th squared, you'd multiply the exponents here, so you get 10 to the 12th. 10 to the 12th meters squared. So now we're in Webers per meter squared. We just have to simplify this. So 10 to the 6th over 10 to the 12th. We're going to subtract, which gets us 10 to the negative 6th. So here we have 6 times 10 to the negative 6th Webers per meter squared. That right there is Teslas. So we have 6 times 10 to the negative 6 Teslas. And that should be what that magnetic field strength is. Let me just take a quick little check here. Quick little check. Yep. That is what it is. Was this not Kuzi? Who asked this question? This was Kuz. Yeah, Kuz. What are you thinking? Are you scared off by that guy in the wig? It was not me. Just believe me on that. It was not me. You are confused. You are confused. Absolutely. Okay. Have you ever seen this type of operation before? Oh. Okay. So you're saying you get it, but you're also confused. Those are two kind of contradictory things. Hey, Slayer Darth's watching. Hello, Slayer Darth. Things go well. Not Kuzi. Have you... yeah, we want to hear a bad math joke. Not Kuzi. Have you seen this kind of dimensional analysis before? Where you multiply by conversion factors that cancel out units that you don't want? Have you seen this before?
Show him something he definitely hasn't seen before.
What does that refer to? Something like that?
He's doing so, yeah.
Yeah, in chemistry.
From Jimmy Neutron.
Oh, that is? That's where they did that for the first time?
When Shane says, that's the stupidest thing I ever heard.
Oh, and he says...
Or Nick says that, and Shane said, no, this is the stupidest thing you've ever heard.
This is good. Slayer Darth says, I find my trig professor hard to follow. They always go off on a tangent.
Ooh.
That's quite good. That's quite good. So 1 megameter is equal to 10 to the 6th meters. But that's a unit of length. And here we have area. That's what we're talking about here. It's a square megameter. They want it in square meters, which is all area. And this right here is just length. Hey, Beth Boy Barf.
Beth Boy Barf, I assume.
Oh, that's extremely good. That is extremely good. I like that tangent one. It's very good. So if you want to turn this into area, you have to square both sides. We want square meters. That's where you take meters and you square them. So if you square both sides, then you'll get the units you want, which is 1 megameter squared. Megalodon is equal to, this is going to be 10 to the 12th square meters. Okay? The reason I did this is because of what's happening over here. There's 3 feet in a yard. That's length. If we want it in terms of area, 1 yard squared, which is a square yard, is not 3 feet squared. I should make sure to put that is not equal to. It's not equal to that. Okay? There are 3 feet by 3 feet in 1 square yard. And so if you multiply those together, you get 9 feet squared. That's how many square feet there are in a square yard. That's what's happening right here. I should have written that before. I'm so sorry. I didn't know. I did know. I just wasn't careful. Levi, it says we have 0 viewers, but we don't. We have viewers. They're saying things. What's happening?
It's just the restream doesn't know.
I'm scared. I'm scared.
He's not scared.
So that is the conversion rate that I used. 1 megameter squared is 10 to the 12th meters squared. And I multiplied across to cancel out megameter squared. I still have the number of Webers we had. I now have that 1 megameter squared is the same as 10 to the 12th square meters. And then you divide. And that's just exponent properties. 10 to the 6th over 10 to the 12th. You subtract 6 minus 12, which is negative 6. That's how you get 6 times 10 to the negative 6th Webers per meter squared, which is a Tesla. So what is 6 times 10 to the 6th in these equations? That's the number of that's the number that they give us. Wait. Okay. So point P has a magnetic field strength of 6 times 10 to the 6th Webers per square megameter. So that's just that's the strength of magnetic field that she has. Meters per square megameter. Sorry, Webers. If you haven't seen, I just don't understand how to read these types of questions. Yeah, you don't need to have seen like magnetic field strength in physics before. This is testing you on your ability to understand units. All right, a Tesla is defined as 1 Weber per 1 meter squared, or 1 square meter. But they're giving us the magnetic field strength in something that's not Tesla's. And we have to convert it into Teslas. And we already have Webers down. 6 times 10 to the 6th Webers per square megameter. That's the problem. So what is W? W is, it's not W times B, it's Webers. That's the unit. That's the unit right there. Weber is it's a magnetism field strength thing. You don't need to know what that is. It's a unit you see in physics when you're dealing with magnetism. So like, I think that they give you more information than you need to know. So like the fact that it's Divya and she's building a circuit, like, doesn't matter. WB equals 6 times 10 to the 6th. Well, yeah, the amount of Webers in this situation is 6 times 10 to the 6th. It's not like that's what WB always equals. That's a unit. It's like saying, you know, in terms of pounds per square inch, you know, this scuba tank has 200 pounds per square inch. It's not like 200 is like a special number. That's just what we have in the situation. Okay. All right, Levi, you're up.
Yeah?
Yep. Got you a good one.
Yeah?
Yes.
Very good. Kuzi, how is life going? When do you start school? Is Kuzi a senior?
Kuzi's a koozie.
Okay.
Actually, no, Kuzi's not koozie. Forgot about that.
Yeah, I always got to remember that. It's actually a logical fallacy. Kuzi is not Kuzi.
You're right.
Or this sentence is false.
Oh,
Something like
jeez.
that.
I don't like that at all.
You don't like that at all?
Not Kuzi says he hates life, or she hates life. Well, just pretend you're Kuzi then, because then you don't necessarily hate life.
Okay, we have the functions g of x equals this thing and h of x equals this thing are graphed in the xy plane. Which of the following is a true statement? Okay, I need to find an internship and sign up for classes still.
Sorry.
All right, so it looks like we just kind of have to go through each of these statements one at a time. So the functions have the same y-intercept. That means we're going to have to find the y-intercept of each of them. Or there's maybe a faster way. We'll find out in a hot sec. The functions have the same x-intercept, so that'll be harder to figure out most likely. The functions have the same axis of symmetry, and then the functions have the same vertex. Okay, well, you got this one right, it seems. Are you just checking on this one? Or what are your thoughts on this? Because you got it right. Do you know how to do it? Or you want me to check any of the others that are wrong and show you how to, prove that they're wrong? What are you into here? And then we will do that thing. I just wanted to find the other answers. Okay, cool. So the functions have the same x-intercepts. This is going to be a little bit harder because you have to find the x-intercepts. But actually, no, it's going to be pretty easy. I'm going to write these equations up here. So we have g of x equals 2x minus 5x minus 3, x minus 5, x minus 3, and then h of x equals 2x plus 5x plus 3. 2 times x plus 5, x plus 3. So for b here, we have find the... I know how to find the y-intercept. Okay, finding the x-intercept is the same thing. You plug in 0 for y now, right? So y-intercept, you plug in 0 for x. X-intercept, you plug in 0 for y. We plug in 0 for each of these y's. They're already factored, so we know that the x-intercept for g of x will be x equals 5, x equals 3, and this will be x equals negative 5, and x equals negative 3. So they don't have the same x-intercept, so b is wrong. Then, and let me know if that doesn't make sense, the functions have the same axis of symmetry. So these are both parabolas, right? If you multiply, you FOIL and you multiply by 2, you're going to get x squared, or 2x squared plus yada, 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 right? So you're going to have parabola going like this. There are going to be two parabolas opening up, in this case, because you have a positive leading coefficient. But to find the axis of symmetry on a parabola goes right through the vertex. So to find the vertex, we do negative b over 2a. So first we have to find, we have to put these in standard form. So g of x will be 2x squared minus 16x plus 30. I guess we don't really need all of this, we just need the b term. And then we get 2x squared plus 16x plus 30. So axis of symmetry is negative b over 2a. And that's not going to work because we have a negative 16 and a positive 16, so they'll be opposite. So the axes of symmetry are not the same. And then the functions have the same vertex. Well, we already know they don't because this is the x value of the vertex. X sub v. Yes, you do. Very good, very good. That's this one. I like this one. There are several things that you need to know how to do. Isn't the axis of symmetry in the middle of the two x-intercepts? Yes, I think you're misinterpreting what they want here. I assume what they're saying is that the axis of symmetry for each individual parabola. They're not saying, are the two parabolas symmetric of each other? It's just, if we have this parabola here and this parabola here, we're not talking about this line. We're talking about this line and this line. And this parabola being symmetric with its left and right, and this parabola being symmetric with its left and right. So they're asking, do you have a parabola maybe like this, and then a parabola like this, and then their axis of symmetry is the same? Oh, you do know that. Okay, so Meh. But yes, if you're doing this, well, these look like a bunch of tridents, but yeah, this would be the axis of symmetry if you have two identical parabolas on either side of it. Yes, halfway between the vertices. Yeah. That's kind of fun.
Let's do a robot question.
Ooh, robots got questions?
Yep. And then, yeah, robots got 2 questions, and then Willie has now posted some questions. So we have one more.
Oh, nice. Hi, Willie.
We got one more Coos question, but we'll come back to it.
Okay.
Robot. Robot dancer.
Should we answer Robot's written question? I started reading it.
Well, if you started reading it, it's too late. I think it's an essay question, right?
No, it's actually not. Okay, which of the following points do not lie on the interior of the circle?
I'm all over this. I'm absolutely all over this.
Can you do it with just that much, do you think?
With half of the question?
Yeah, with half of the circle equation.
No. Nakuzi, PSI is pounds per square inch. It's a unit of pressure. Air pressure. Pounds of air per square inch.
What did I just do?
That is not what we want. So like if you say, what's the air pressure at this point that we're living? There's what's the normal air pressure of like sea level?
773 or 733 or something? Right?
You're thinking of milligrams of mercury.
Yes, I am.
Yeah. Oh, jeez, that's going to kill me. 14.7 psi. Thank you. Anyway, all right, so we have a circle here. And if you know your circle equation well, you'll know that this equation tells us the center and also the radius, okay? So, real quick, here's the graphing a circle equation. X minus h squared plus y minus k squared equals r squared, where h comma k is the center of the circle, and r is the radius, predictably. Okay, so in this case, I need a better arrow. Okay, in this case, the center is going to be negative 2 comma 2. Negative 2 comma 2. And then the radius is going to be 7. So what this circle means is that it is all the points that are 7 units away from negative 2 comma 2 in all directions. I will sketch out a little picture here, just so we can imagine. It's going to be kind of fun. Y, x. Okay, negative 2 comma 2. It's right there. And we're going to go 7 units in all directions. So if our y value is 2, we can go up to 9. That's how high we're going to get. 3, 4, 5. It's going to be up here-ish. And then we're going to go 7 units down, which is going to get us down to negative 5, which is going to be around here. And then we got this, and then we got this. This is our circle right here. So conceptually, you got to understand exactly what a circle is. Circle has all to do with distance. All the points that are on a circle are a certain distance away from the central point. We call that distance the radius. So if you're not lying in the interior, that means you must be outside the circle. I guess you could also be on the circle itself. But if we just figure out the distance between the central point and all of these points, then we'll know which one is too far away to be on the inside. So right off the bat, I'm looking at B. B is the same point as our center. So clearly B is inside the circle, and they want one that is not inside the circle. So that right there, that's gone. Okay, so let's look at A first, negative 8 comma 5. So the way to find the distance between 2 points is to use the distance formula. Distance formula, if you don't know it, looks like this. And it's based off of Pythagorean theorem. I like just drawing a little picture and labeling the sides of a right triangle. So if this is our center, which is negative 2 comma 2, if we're looking at negative 8 comma 5, that's going to be around here. I don't know exactly where it's going to be, because if it was easy, I'd know if it was inside or outside. But let's say it's right there. So if that right there is -8 and this is 5, then in order to figure out the side lengths of this triangle, we're going from -2 to -8, and that's a distance of 6, and then we're going from 2 to 5, which is a distance of 3. So we can just use 6 and 3 as the side lengths of our right triangle, and if we do that, we're going to get 3 squared plus 6 squared is equal to c squared. 9 plus 36 is equal to c squared. C is equal to the square root of 45, which is c is equal to, which is 3 times the square root of 5. Now, I need a calculator because I do not know what that is. You know what? Although 45 is between 36 and 49, so it's going to be somewhere between 6 and 7. And right here we have a radius that is 7. Okay, so if it's between 6 and 7, it's not 7. 7's too big, which means this thing will be inside the circle after all. If you put 3 root 5 in your calculator, you're going to get 6.8 or something like that, and you'll see it's inside the circle because it's not yet far enough away to be 1 radius away from the center. So that right there is also gone. 1 comma -4, that should be a nice one to test. So the x differences, because I like to think of it in terms of like your d squared, your distance squared, is delta x squared plus delta y squared. Delta is the Greek symbol for change. It means the difference here. So the change in x, the difference in the x values squared plus the difference in the y values squared. So our center is -2 comma 2, and then for c, the difference between the x values would be -2 unto 1, and that difference is 3. So that's going to be 3 squared plus, and then the change in y is from 2 to -4, which is 6, which is exactly the same side lengths we saw as before. So that one cannot be right, which means this one's going to be right. But the reason why this thing is going to be right, let's just figure that out first. The difference in the x values is from -2 to +3. That's 5. That's 5 squared. And then the distance in our y coordinates is from 2 to -3, which is also 5 units. So 5 squared plus 5 squared equals c squared. If you know your 45, 45 right triangles, if you have two sides that are the same, you have an isosceles right triangle, your hypotenuse is going to be 5 root 2. And 5 root 2 is like 1.4-ish, 1.4. So this is going to get you, let's see, 5 plus 2.5. It's going to be a little bit more. You got your calculator?
Yeah, what's up?
5 root 2.
5 times square root of 2, 7.07.
7.07, yeah. That's larger than the radius. So it is further away from the center than all the points on the circle, so it's outside the circle. That is why that is your answer. What do you want to do next?
There is a great Willy question that I like that I started out up there.
Got it.
So I will do that.
All right.
Willy, are you here? Say hello.
Wave hi to the camera, Willy.
Do it.
You're on national TV. Oh, Willy's here. It's Cookie God.
Actually, technically, not international TV.
No.
Very exciting.
If no one's watching it from another country, is it though?
Yes?
Really?
I think so. Let's do that like that. Pull it there. Okay. Okay. How do we do questions like this? These are actually not that bad, and actually not even that time-consuming. They just seem very time-consuming. So we start out with this given. I cut it off and I have it written here for ease of space on board.
Spaceys.
Yeah, space ease. Yes. The way that I recommend doing these that saves a ton of time. First of all, you have to understand how radicals play with exponents. If you don't know that, then that is the actual skill you need to have. And then the approach to these saves a ton of time. What I would recommend is you put all of your answers in exponent form, not in radical form. Radical form is tough to mess with. If you just do exponent form, it'll be very clear. Okay, so all of these answers should go into exponent form because radicals, there are several y's and x's and things like that. What I would recommend
And then, on top of that, only do one variable at a time. We're going to try eliminating answers here. We're not trying to find the right answer directly. We're trying to eliminate answers. So what I want to do is focus only on the x and just get from here to x to some power. We want x to some power. That would be -2 by quotient rule, -2 minus 1/3, which would be -6/3 minus 1/3, which is -7/3. -7/3. We are shooting for this, x to the -7/3. Do we have that in A? We have, it looks like x, it's going to be a negative power because it's on the bottom, to the 2/3. So that's wrong. We don't have to check the y at all. That's how fast we can go through. Next one is exactly the same, so it's wrong. We don't have to check y. Next one is we have x to the first times x to the 1/2, which will give us x to the 3/2, which is not x to the -3. Oh, sorry, it would have been negative each time. My bad. But still wrong. It's x to the -3/2. And then here, it's going to be the right answer. We have x to the -2 times x to the -1/3, which would be x to the -2 minus 1/3, which is what we did originally, which will give us the right answer. We never have to check y at all in this case.
It's pretty clean.
It is significantly faster than any other way
Known to man.
I've ever seen. Known to man.
And Levi's seen a lot of ways.
Yeah.
He's a waysman.
Yep.
Wasn't that your previous job before this?
Isn't that sick? I agree. These questions are really challenging, but then once you understand to take that approach, they get really fast. And you
Yeah.
can save time on these because they are expecting you to take a long time.
You might get nauseous with how fast they are.
Yeah. So make sure to do the spotting thing where you hear, and then as you're doing the question, come back around to there. Okay?
To prevent nausea
Yeah.
from occurring.
Mm-hmm.
Yeah. Someone took some ballet.
Yeah.
Yay!
But it is sick. And you know, if you only eliminate A and B, then you have to go to the Y's and do and figure out C and D.
I heard something good this weekend.
Yeah?
You ever heard of bingo gobblers?
No.
Okay, so if you go to like an old folks home, how do you know that X would be the denominator? No, because if you do, well, you can explain it. I'm not gonna.
I don't entirely know what you mean.
How do you end up?
So this here, I just found what x, you know, it's x to some power. It would be x to the -7/3
He's got
based
it.
on that
He's
stuff.
got it.
Oh, never mind. Yeah, okay. Wait, why was d -2 and -1/3? Because the x's are in the denominator, so I just said, bam, put them in, just make them negative. Because I'm going for x to a power. This is not 1 over x. This is x to the -7/3. That's it. These are all x to that, x to, well, it's the same, x to those things, x to those things. So I'm no longer dealing with fractions. I make everything just x to a thing.
Cookie guide, yes, denominator. So bingo gobblers, if you go to bingo, which is typically old people,
Yeah.
when old women win, they say bingo, and then you see the gobblers on the bottom of their arms.
What?
It's bingo gobblers.
That makes sense.
Yeah, it does, if you think about it. All right, that was Willie, right?
Yeah.
All right. So, let's see what else we got. We got some great Willie questions here.
Willie asks great question. I think we owe Kuz a question.
Yeah, we do. This is the last Kuz question.
Although we did do a couple Koozie questions in a row.
True. I like where you're
Brady's
going with
bullying
this.
old ladies because Brady's grandma bullies him, and so Brady is continuing that really carnivorous cycle. Because
Yep.
It's carnivorous because all old ladies eat people,
All right, you want to do
and all
robots?
Bradys eat old ladies.
What?
Yeah.
That's simply not true.
And when you grow up, you'll be an old Brady.
That's very true. So Levi, can we do that?
Oh, I already answered this. You don't have to do it.
All right. Well,
Yeah.
then that robot doesn't have another question. We're gonna go to Kuz.
Yeah. Bum, ba-da-dum, bum, bum, bum.
Nice.
Ba-da-da-da.
Nice, dude. Are you working on that?
Is this more exponent stuff?
Yeah. A little bit.
A little something, something.
Lil something something.
Yeah.
Why is Brady bullying old ladies? Because they let themselves get old. Which is on them.
Oh my gosh.
Oh, it's good to be young, isn't it? We'll never be old. This is the first generation that is just going to stay young, unlike all the generations before us. You know, 100 people, sorry, not 100 people, 100% of humans have died, except for the ones that are currently alive. So we're not sure.
It's actually not true.
Well, right, because it's not, because the people that are still alive.
No. That's not true.
Explain.
What? Like so say what you said again?
100% of humans that have lived
Yeah.
have died, except for the ones that are currently alive.
No.
You're gonna have to explain.
No?
Yes. That's how we do things.
You have to prove that they're dead.
Okay. Is your great-great-grandfather alive?
Maybe.
Really?
Yeah. I never met him because he's dead.
Well, you just said that he's dead!
No!
Yeah!
Do your math, bird.
Is that what they said?
Mm-hmm.
Oh, do your math, bird. I'm just saying.
Go.
Go.
Easy, Brady.
Go.
Easy.
Go.
You almost got in trouble.
No, I didn't.
Yeah, you did.
I was just going to tell you to stop.
I knew that.
All right, which of the following is equivalent to the above expression?
Hey, pause. Hey, Kuzi, I think Robot Dancer isn't able to watch streams, so they just put questions in the Discord. I think those questions are from you, World. Like you and then World. I'm also possibly wrong.
Me world. All right, well, I'm just going to direct your attention to with A. N minus P over 2 is the same in A. They have that as well. But somehow you took N squared P squared and you assume that that was equivalent to P squared N squared over 2 over 2. It's weird to say that. Which would be, if you multiplied those two terms together, you get P squared N squared over 4. Which would just be saying you just put a 4 under here and said it's the same thing as it was before. Which you cannot do. I don't know exactly if this is better to just start multiplying things or to just simply figure out which of these answers is wrong. You know what? Yeah, we're going to figure out which of these answers is wrong. So, like I said, with A, N minus P over 2 is the same as is, yeah, it's just an A, but then they're turning N squared P squared into that second part. P squared over 2 times N squared over 2, which if you multiply those out, you're going to get P squared N squared over 4, which is not the same thing as what we started with. So we cannot do that. Big fat X on that. The next one, with B. It looks almost identical to our original expression, but they changed N minus P over 2 to N plus P over 2. They shouldn't do that. You can't do that. It's not going to be equivalent to that. You can't just change a negative to a positive unless you're Levi. So that is also Dunzo Garbanzo beans, which I'm still trying to start. It'll get there. Okay? Now, number 3. It looks like what they did here is they took N squared and P squared, which is what we had at the very beginning, and like Moses in the Red Sea, they split them apart and threw P squared over to the other side of what's in the parentheses, which is fine. You can do that. Let's just see what happens. So we have N minus P over 2 times P squared. All right? Multiplication, it does not matter what order you multiply things in. 5 times 3 is the same as 3 times 5. It's called commutative. It's a commutative property. It reflects that it's... Anyway. So we're allowed to do that, but then there's this added thing, which they made the inside a little different. They gave us 2p minus 2n over 4. So we can simplify that a little bit. We can pull a 2 out of all of those, which gives us p minus n over 2, which is not the same thing as n minus p over 2. They flipped the order there, so that is not equivalent. Which leaves us with d, and let's figure out why d would make sense. Yeah, okay, so okay. I'm going to combine the first part of d with the last part. So p squared over 2 times some stuff times n squared over 2. The p squared over 2 times the n squared over 2 is going to give us p squared n squared over 4, like we talked about before. And then they have this new thing in parentheses, which is 2n minus 2p. Can we show that that's equivalent to what we started with? Interesting. Well, let's factor 2 out of both of these. So we still have this out front, p squared over n squared times 4. But now we have 2 times n minus p. Okay? Same thing as what we had up there, we just factored a 2 out. The 4 and the 2 will have some moderate cancellations. The 2, this will end up on the top. So we divide the top and bottom by 2. That gets rid of the 2 up there, and that's going to turn this into a 2 down here. So what that gives us is p squared n squared over 2 times n minus p. And this is almost identical to what we started with. They just take the divided by 2, and they move that underneath this part of the expression instead, which, again, you are absolutely allowed to do. If anyone tells you can't do that, they're wrong. Times n minus p, but that is now over 2, because they just transferred that over. So it will be D. That is going to be the correct answer for this one. Woo! We love that. Any questions? David S. Pumpkins. Tom Hanks. No. I want to do the thing.
No, you don't.
Oh, you're right.
You know not what you ask.
Willward.
Yeah, the second one. Yeah. Let's do that. Willie, I took a look at this. Are you still here, Cookie? Because I think you might be a little frustrated with yourself, possibly, when you see what you missed here, because you did everything fine. And then I think either you're uncomfortable with this question type or you just misinterpreted it a little. So your work was correct. You distributed your stuff and you added and you combined your like terms. So I'm just gonna do that really quick. Bird, can you erase that actually, possibly?
Oh,
Thank you, Bird.
oh,
My favorite bird.
oh.
Okay, so we're gonna have 7532 plus 100 y squared. Then we're gonna add another 100 y squared. And then we're going to subtract 220. Yeah? And then we combine our like terms. So these two guys become 200y squared. And the other two guys become... Oh, wait. That's maybe what you... Let me just check your work real quick, Willie. You may have just made an arithmetic mistake. Yeah. Oh, no, I did. You're right. I did. That makes sense. Yeah, I knew it wasn't looking like yours. This doesn't make any sense. Good call. Good call. Okay, so this is 1100, and then we're going to subtract it from the 7532, and we get plus 6432. Yeah? Now we're pretty much done. They are asking for the value of A and B. And the way they do it is they say we have A times y squared plus B. So they say the expression above can be written in this form, which we now have, right? We now have ay squared plus B. Yeah, there you go. So I'm not sure what you missed here. It seemed like in your work you started taking the square root of stuff or something. Yeah, it's just 200 and then it's plus B, right? So 200 plus 6432. Whatever that is. What happened? Yeah, no idea. What happened to what? I don't know what you're talking about, Coos. Yeah, so it's 6,632. That would be the answer. Nice and simple. You made a mistake. There you go. Keep an eye out for it. They do this setup a lot. You know, they'll give you something relatively complicated, and they'll talk about constants. And most of the time in high school, we don't talk about constants. We talk about variables. So when they talk about constants, take your time. Sometimes it's very complicated. Sometimes it's that mirroring thing where the two sides have to be equal for all values of x. You know, and then you have to find a, b, and c sometimes. In this case, it's way easier than that. You just do it. I don't know. I write dumb stuff when I take time tests. Good. Write less dumb stuff. I'm being super serious. What I would recommend here, if you make simple mistakes on the math test, Cookie, are you getting, are the only mistakes you make just simple mistakes, or are you still making mistakes on conceptual things that are just really challenging? Yes. No. Okay. So if that's your biggest problem, what I recommend is, okay. Here's what I think you should try on the next practice that you do, and I don't think you should do it in along with the English sections. I think that you should take a math section and you should give yourself 1.5 times the amount of time allotted, or twice the amount of time allotted, and do not get anything wrong. Now, if you really don't know how to get an answer, that's one thing. But you need to practice being perfect. Go for the accuracy first and then start speeding up. But you have to get everything right. And also, you're not allowed to go back and check your work. So it's not about finishing and then going back. It's about doing everything right the first time. You don't have time. You probably don't have time to check all of your answers anyway. So there's no point there's sort of not really much of a point in checking any of them. You should just go slower if you're making simple mistakes. I'm not saying that that's how you're going to do the actual test, but you need to practice being really accurate first and then go to efficiency. It does genuinely help because at the moment it sounds like you're just practicing making simple mistakes, right? So you got to practice being perfect. Okay. Let's see what else we got here. Do we have a koozie question? We have another Willy question. Koozie says, preach. Very good. Yes, 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 yes. Bird, you're up.
You want to do another one?
No, do you?
Yes.
All right. The shipping service. Also, Bird, I'm on book 11. Pretty exciting.
Out of what, 14?
Yeah.
There's 14 books?
Yeah.
Oh my god.
The guy died before he finished them. So.
I know. I heard.
Yeah.
That's awesome. I mean, I don't know why I said that. 14. A shipping service. Levi, should I get angry?
Yeah, I think so.
Like aggressive? For the question?
I think so.
Okay. Here we go. A shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and the length of the box. If a box has a height of 60 inches and its length is 2.5 times its width, which inequality shows the allowable width x in inches of the boat? The box. I'm sorry. There's probably a boat somewhere in the situation. I didn't understand a word I just read because I was screaming it. So give me 1 second. Okay, so I'm going to start with this thing that was underlined. So the sum of the perimeter of the base of the box and the height of the box. So the perimeter of the box, of the base of the box. Let me draw a little box here. Just a little box. There we go. Okay, not a great box. So we're going to have the length, the width, and the height. So the sum of the perimeter of the base of the box. If I'm going to call this the base of the box, the perimeter of the base of the box is going to be 2w plus 2l. I'm going to make this into an L so it's easy to see. All right, so perimeter of the base is equal to 2w plus 2l. And they're saying that the sum of the perimeter of the base and the height of the box cannot exceed 130 inches. So it can be 130, but it can't be above that. So if we put those together, 2w plus 2l, the base of the box and the height of the box, needs to be less than or equal to 130. We're going to start with that. We might need it, we might not. I don't know. I just like turning sentences like that into equations, and so should you if you want to do well on this test. The perimeter of the base is determined using the width and length of the box. Okay, so I labeled that well. I probably should have checked that, but that's for what I did. If a box has a height of 60 inches and its length is 2.5 times its width, which inequality shows the allowable width? Okay, the first thing is nice and easy. The height is 60 inches. So I'm just going to throw that in for height right here. So 2w plus 2l plus 60 is less than or equal to 130, and I can simplify that a little bit. 2w plus 2l is less than or equal to 70. All right. Then we have the fact that the length is 2.5 times the width. So that's a new piece of information for us. Length is 2.5 times the width. See how I wrote that in like translating it from words to math? You got to do that. So that means we can do a substitution here. We can put this in for our L right here. So our W is going to stay the same. This is still going to be 2W. But now it's going to be 2 times L, which is 2.5W. And that is going to be less than or equal to 70. So now we have 2W plus this is going to be 5W is less than or equal to 70. 7W is less than or equal to 70. Divide everything by 7. W is less than or equal to 10. Now, if you look at your answers, the thing that matches up best with that is A, but like the 0 is less than X. What's going on with that? Well, your width can't be 0. The width exists in the real world. You can't have a negative width. If the width is 0, your box isn't a box. It's just a flat piece of cardboard with no width. I don't know. So that's why W or X needs to be greater than 0. And it can go up to 10 or be less than 10. That is what this is. Cookie God. How'd you get 2.5 again? It tells us down here that its length is 2.5 times the width. So I turned that into an equation. Length is 2.5 times the width. And because I could use that for a substitution. Got it. Okay. Excellent. We will continue then. Levis.
Yes.
Would you like to do the next one?
Is there a next one?
There is always a next one. Yes, there is. Kuz.
Oh, Kuzi, you put more. Yay.
A lot of exponent stuff today.
Yeah. I think this is the same thing.
Very similar.
The last one.
Very similar. I'm going to make this crop tight. Tight crop. And I can just do it in 2 strokes with using both corners. Someone once told me that. Levi, this is you.
Yeah?
Oh, yeah. I don't know how to do it.
I actually don't necessarily either. Okay, so we got this thing, and it is 6 to the 1/2 plus 6 to the 3/2.
Here, I'll make this big.
Great, so that's where we're starting, and we need to get to one of these answer choices. As I said before, always look for the green answer choice, pick that one, move on. It makes it a little bit easier.
We don't condone violence. We don't condone it.
Oh, we don't condone it? Are you sure?
We don't condone violence.
Okay. So we're trying to get to one of these answers. I'm going to say let's try eliminating this time. Does D make sense? I wouldn't say so. 36 means it's going to be 6 squared, right? 6 squared would happen if you are adding the exponents, but you can't be adding the exponents because you're adding the bases. You have to be multiplying the bases to add the exponents. So 36 has to be wrong. You can also, I'm guessing you're not allowed a calculator here. Then we have 6 to the 3/4. I'm not sure we can get there. I'm going to try the same thing as last time, Brady, because, yeah, we can't use one of the normal exponent rules. But let's see if we can pull something out. If we pull out, let's try a 6 to the 1/2 power. If we pull that out, we get 1 plus, and then we'll get a 6 to the 2ths power.
Teeth.
6 to the teeth power. Better?
Yes.
Okay. And you can see if we distribute this back in, we get 6 to the 1/2 times 1, which would give us 6 to the 1/2. And then we get 6 to the 1/2 times 6 to the 2/2. You add the exponents, you get 1/2 plus 2/2 is 3/2. So this is true. Now, we'll rewrite this as 6 to the 1/2 times 1 plus, well, 2/2 is 1. 6 to the 1 is 6. So it's just 6. And now we have 6 to the 1/2 power times 7, which would give us B. Six to the 3/4, I'm not sure how you would get to that. I can't disprove it particularly well. And then rad 222. How did you come up with that, Kuzi? I'm looking at the reasoning that they said doesn't work. Yeah, you can't pull out the... You guessed. Okay, great. So guessing on these type of problems only gets you the right answer about a quarter of the time, so don't guess. Actually, don't listen to that. You should guess if you don't know what you're doing, obviously. Okay. So this seems to be one thing. I have never seen this type of question on the SAT. I've never seen this where you have two exponents added together and you have to pull, factor out a base to some power. I've never seen that. It could come up. I wouldn't stress about this type of question too much though. And then I can do the next koozie question as well, unless you want to do it, Bird.
Do it.
It's got to do with atoms though.
You do it.
Okay. All right. So the path of an atom. The path of an atom where x is the east coordinate in millimeters and y is the north coordinate in millimeters. Okay, so let's visualize that. That's just an xy plane, right? And it's just the first quadrant, right? The x is the east coordinate and the y is the north coordinate. So that's actually not too bad. And then it's that distance from a sensor. So the sensor is at the origin. I think that will make this problem a little bit simpler. Then we have this equation, x equals this function of y. Among all points along the atom's path, what is the smallest east coordinate in millimeters? Okay. Koozie, is this a calculator question? I'm just wondering. Bum. It is a calculator question. What I would recommend is plugging this into your calculator, and then we're looking for the smallest east coordinate. Let's see what we can do with that. We have x equals y squared minus 4y plus 5. I'm going to factor this. Now I know that it's x in terms of y and y is squared, so that's weird. This is not a function, because it won't pass the vertical line test. But let's rewrite this as y. Oh wait, that won't work. Okay, so we can't factor it nicely. That's a bummer. So let's see if we can sort of reason out what's going on here. Let's start plugging in some points. What is the x-intercept? The x-intercept is when y is 0, right? So we plug in 0 for y. Those both go away. We get x equals 5. So we know we have an intercept there. And then we know that as y increases, x is also going to increase. This is going to come out in this direction would be my guess. It also... Yeah, so what I would recommend is just graphing this. I don't want to, pick points and find them all. Graph this on your calculator and see what you get. Bird, can you graph this for me?
On a calculator?
Well, it doesn't have to be on the calculator. It could be on your phone or something.
What do you want me to graph?
Can you see my Desmos? Whoa, that's weird. Oh, no, it's not. Never mind. X equals y something.
Just go on your Desmos.
X equals y. Where's y? Y squared minus 4y plus 5.
Is it a sideways parabola?
Yes.
Y squared minus what?
Okay. Oh, great. That's very nice.
Say it again.
X equals y squared minus 4y plus 5. So we'll see on the graph it looks like this that we draw. You can hey, Stealthy Sumo, didn't see you there. So how would I graph this if x equals y? What kind of calculator do you have? You can switch the x and y. There are ways to graph this with your calculator without killing it. TI-84, Bert, do you want to talk about graphing this type of thing on TI-84?
Let me figure this out real quick. I don't think I've ever switched these before.
You guys have to give Brady a second. You can also think about it this way. If you just switch x and y, they're in your head. They're asking about the minimum value of x, right? What is the farthest, the smallest east coordinate? So the least far east, the farthest west, farthest east. So they're looking for the vertex. So you can find the vertex by doing negative b over 2a. Now y will be that will give you y, so that would be negative, that would be 4 over 2, which is 2, so that will give you 2 for y. And then you plug that in for y to get x, you get 4 minus 8 plus 5 is 1. So this point is 1, 2.
Yeah, you know what? I don't know how to turn my calculator to x equals.
Yeah, so I would recommend switching x and y. I haven't seen that on the SAT either. I don't think you'll ever have to do that on the actual SAT or ACT. Math 2? Yeah. Very good. So you could rotate the calculator, yes. It can get a little messy when you go to other quadrants, but in the first quadrant it's fine. Okay. Do we have more stuff to do? Kuz, do you have more questions? No more koozie questions.
You love that Shrek song, don't you?
I do. It's in my head.
Bye.
Sorry. So the answer would be the minimum x. Yes, which is 1. Yep. And I found it by doing the vertex, but that negative b over 2a in this case would be used on the y, and then you have to plug in that value for y to find your x.
I'd like to do the next one, please.
There is no next one, Brady. It's all over.
Wait, there is a next one. Oh, no. You're right.
Yes.
You want to tell them about commas?
Commas?
Yeah, you know, commas. You'll get what's a common to you?
Yeah. Kuz, you want to talk about commas? Or semicolons or colons or anything on the writing section?
I just made that up. I don't know what we want to talk about.
Yeah.
Who's got questions, huh? We've got answers.
I have a hard time with word problems and converting them to equations, do you?
Oh, really?
Oh, wow.
Well, you've come to the right place.
It's dark in here.
What?
I don't know. Not the easy word, but like exponential. Okay.
Okay, I can wrestle up. Let's see what Levi can wrestle up.
It's gonna take a sec.
Yeah, it's gonna take a sec. Looks like you're looking down at Accelerate.
Yeah?
Yeah, a little bit.
I don't think so.
AccelerateTutoring.com today for you. If you go to Khan Academy and go to SAT practice, give you some directions.
Kuz. How do these questions look? Are these too easy for you?
Are these too easy? Huh? Why am I so tired?
Lack of sleep.
That's probably it.
Yes. That's system of equations. Yeah, number 3 is systems of equations. Okay, so you're fine on those. How about number 4? That's getting into the realm of exponential stuff. Sort of. 4 is D. Yeah, okay, so you don't need that. Ugh, shoot. Let's see, what else we got here? Maybe this one. Yeah, this seems a little better. How about this? Number 1 is probably a little easier, or is a little easier than the other couple. How's number 2 for you? What say you, Kuzi? That's right, yes. Hey, Bird.
Yeah.
We got a from Kuzi, so you're going to do number 2. Since I wrote this question, you have to do it.
Okay.
Now Kuzi says that would be C.
I don't know.
Make it big. Make it big. Yay. I don't think they know what we're even saying. We make our screen size expand so we can read everything. So when we say make it big, it probably doesn't mean anything to you, but it means something to us. Aman puts $2,000 in an account that gives him 2% annual interest compounded monthly. Which expression shows how much money will be in his account after T years? Okay. Huh. Well, you got to know the formula for interest. Y is equal to principal 1 plus r over n times nt. And Kuzi thinks it would be C. The principal is $2,000. 1 plus our rate is 2%, which is 0.02. Number of times we're compounding every year is monthly, which means there's 12 times a year. And then that means it's 12t. So you're very close, Net Kuzi. You're very close here, but it is actually A. We don't take years and divide by 12 because we want the exponent to be 1 after a full year. We get 2% every year. We want to multiply by 1.02 at the end of the year. So we want our exponent to be 1. So 12 months. All right, now wait. After T years. Yeah, okay, yeah, that makes sense. After 12 months, we've compounded 12 times. And 12 months is 1 year. So after 1 year, we've compounded 12 times. All right, this is making more sense to me now. So if T is 1, that means 1 year has passed. We're multiplying that by 12. So we're going to be multiplying by this multiplier 12 times. We're taking it to the 12th power, which makes sense because we're compounding it 12 times a year. All right, so this right here, this formula is for compounding interest. Have you seen this before? Do you want to talk about it? Do you like it? Do you not like it? Are you wondering? I swear, every other second I'm yawning.
That's good.
No, it's not. I haven't seen that. Ah, not because you haven't seen that. Okay. Well, then that is what we'll discuss. Levi, what time we got?
7:14, my lord.
Got it, my lord.
I have a child at 8, or at 7:30, sorry.
Okay. Well, I have a child at 8.
I know.
You're going to have to go a little bit before
Put
7:30.
it in the teacher.
I did, didn't I?
You didn't you?
Okay, so now Kuzi, you haven't seen that part of it. I'm guessing, though, that means that you have seen the one that is not that should be a P. The simpler version. Have you seen that? Not Kuzi. Yes, we do. Okay, good. So that's with compounding interest once a year. So if you make 5% interest, then your R value is 0.05. So your formula turns into this. Your principal, the amount of money you put in at the very beginning, times 1.05 to the t. Okay? To the t, the exponent, because every year we take 5%, we increase it by 5%. And increase something by 5% is the same as multiplying it by 1.05. So if it's been 5 years, then our t is 5, and we're going to be multiplying by 1.05 5 times for every single year, which is why we use an exponent, because exponents are for repeated multiplication. Excellent. If we are compounding more than once a year, so let's say we're compounding every 6 months now. So I'm going to make a little divider. Okay. So if your interest rate is 5% and you're compounding every 6 months, you're not going to be getting 5% every 6 months, because that would be a hilariously large amount of interest to make. Actually, 5% per year is also not what you're ever going to get. That's way too high. What they're going to do is they're going to take that 5% and they're going to split it in half, 2.5%. After 6 months, you get 2.5%. After the next 6 months, you get another 2.5%. So over the course of the year, it's almost like you get 5%, kind of. It's not going to be exactly the same, but it's close. So the way that we figure this out, our new formula starts the same, but we have to take our rate and divide it by the number of times we're going to compound per year. That's what n equals. Number of times compounding per year. So in this example, because we're compounding every 6 months, that is twice a year. That's where we're going to get this 5% divided by 2 business. Okay? So I'll write that in a sec. Okay? I'll write that in right now. Okay, so that's 0.05 divided by 2. Then it's the exponent. Okay? How many times over the course of a year will you be compounding? Well, if it's every 6 months, a year is 12 months, that's going to be 2 compoundings. So you're going to multiply by your 1 plus 0.0225 twice. One after 6 months, and then again after 12 months. Can't even speak right now. Jeez. So what that means is just taking it to the t is not going to be enough. Because after 1 year, you'd only be taking it to the first power, which means you're only going to be lifting it up by 2.5% once when you want it to be twice. So what we do is we throw 2 in front of this, because for every 1 year, we're multiplying that by 2. 2 years is 4 compoundings. 3 years, 6 compoundings. That's what this 2 does. So this 2 and this 2 are because of the same reason, which is we're compounding multiple times a year, which means they're taking our interest rate, they're going to divide it, so it's a little bit smaller every time we compound, but we're compounding more often, which is what this 2 is going to take care of. Interesting. It's extremely interesting. Absolutely. So the overall formula looks like this. P times 1 plus r over n to the nt. Now you might wonder, is it better to have it compound once a year in one thick chunk of 5%, or maybe twice a year, 2.5%, or maybe even 4 times a year, or 6, or 8, or every month, or every day? And those are very good questions, and there is an answer to this, and I don't want to give it away because that would ruin the learning aspect from your perspective. But if you have some time, maybe right now, maybe after the stream, I would try a couple problems here where you've got maybe 5% interest and you've got $100 in the bank. $100 is super easy because it works with percentages extremely well. 5% increase would give you $105, stuff like that. And figure out, is it better to have it compound fewer times or more times? I used fewer correctly.
Yes, you did.
Yeah. Did you hear that?
I did.
Did you think about it?
I wasn't thinking about it.
But did you think I was going to say something about it because I got it right?
Yes.
You knew I was going to say it?
Yeah.
More times. Well, if it's 5% and we compound once a year, that's going to bring us from 100 to 105. Let's imagine we do it every day. So that's going to be 100 times 1 plus 0.05 divided by 365, taken to the 365 times 1, which is for that 1 year. Okay? Very small percentage at this point, but we're compounding a lot. Try this on your calculator. Do you have one with you? If not, well, just, yeah, try it. If not, let us know, and I don't want to have to do it for you. Wait, let me get it. Good. Not Koozy's going to do it. Not Koozy's learning. That's what he or she is doing. 0.05 over 365 to the 365.
Oh, Master Levi.
Yes, Master Brady.
My lord.
Yes.
Will you...
There is another question.
As another question.
Yeah. There is one more question.
Cool's what?
Perfect question.
Don't erase this. But not Koozy's going to do this, and then we're going to talk very quickly. Not Koozy, that can't be right. Is there any kind of decimal?
.13.
Yes, there you go. Yeah, okay. It's not a lot, but it's more than that. And if we're talking about a lot of money in banks, and money just makes money as interest builds, this does end up turning into a lot of money, okay? As it turns out, as you compound more and more, you start seeing this weird number pop up, which is E.
It's pronounced
No, it's not. That's the schwa. That's the upside down E. It has to do with growth. E has to do with growth. It pops up and stuff. And yeah, it's a fun time.
Okay, so we have this sector here. I'm going to try to knock this out nice and quick. So we have a sector, and we're told that the area... We're basically... We don't need any of this information over here in this word problem. It's just what's in this picture, and we're trying to solve for r. That's all that's happening. 1.2 is in radians. So if we have a sector, and it's 1.2 radians, then we need to figure out what the whole circle is. That's what's going to help us. And we have an area of 3.6 square meters, and then we have a radius of r. We're trying to solve for r. Whenever you have sectors, you're going to be making a proportion, most likely. The proportion will be your piece over the whole thing equals your piece over the whole thing. So I'm going to write that up here. We have, and since we're dealing with area, we'll do the sector area over the circle area. Just write it out, I guess. Equals the, let's say, sector angle over 2 pi or 360 degrees. That is the proportion we're setting up. So the sector area, please let me know if this doesn't make sense. I will explain this concept. But assuming you understand that, then this becomes very straightforward. I'm confused about the radians part. Okay, yeah, the radians part just makes it so that this is not pretty. You can't do this by hand. You'll have to plug it into a calculator. So we're going to have the area is 3.6, and then of the sector, the circle's area will be pi r squared, and that will equal the sector angle, which is 1.2, and the total angle of a circle is 2 pi radians. And now we're going to solve for r. So does this setup make sense? If this setup makes, you got that? Maybe. Then from here, no, you're not happy about this. Okay. So if you get that, then this is just plugged in information. That's all it is. Sector area we're given is 3.6. So we put that in. Oh, never mind. Very good. Great. How is 3? Okay, lovely. So you get that. Good. Oh yeah, this times 3, so we're going to multiply by 3. That's actually cool. Thank you for pointing that out. We multiply by 3 here, so we're going to multiply by 3 here. Also, the pi's cancel. So now if we double 2, sorry, we have 2 times 3 has to equal r squared, so we get r squared equals 6. So r equals the square root of 6, which is b. There, you're done. Or you could, I guess you could cross multiply, but you're solving for r here. So you just do whatever you got to do. Isolate r. It's going to be the positive square root of 6, not the negative square root, seeing as we're dealing with distances, the length of a radius. Do you have any questions on this approach, Kuzi? This is super important. This area thing could be replaced with the sector, the arc length, and then the circle's circumference. So you can do area to area of your sector, area of sector to area of the circle, or the arc length of your sector to the arc length of the circle, which is just the circumference. It seems like you're fine, so that's that. And Bird, I'm going to need you to take over because I have to prep for... You got it. Good. Very good. I need to prep for my child. Kuz, you get Bird all to yourself.
How about that? Not a lot of people in this world can say that.
Hey. Oh, speaking of Bird, what is alta ipsum?
Alta ipsum is a way to take all your stress from academics and plug it into a robot. The robot will tell you what to do with your time studying, putting your essays together, assignments. It's free for a month. Use it for your life.
Yes, all your life.
All right. Now that he's gone, we can get down to some real business. Oh, he's still here. I didn't mean that, Levi.
Yeah.
Finally. Right, I know. Seriously. Well, we have about 3 minutes. So this is 3 minutes of just pure, unadulterated, unadult Brady. That's all you get right now. What do you want? What do you want? Let me tell you about Levi? All the secrets, intricacies that make up Levi? Post the last question. Okay. All right, we're going to do this last question, and then we're going to call it a day. Interesting. Let's see what we got here. I would also like to hear that. Well, now we got this question. You can't have both. Okay, so y to the 1/2 times the cube root of all that stuff. Which of the following expressions is equivalent to that expression, assuming y is greater than or equal to 0? Okay, just a quick little fun thing. The reason why y has to be greater than or equal to 0 is you see this first part, y to the 1/2, that's the square root of y. You can't take the square root of y if y is negative. Y could be 0, that's fine. You take the square root of 0 all day, it just keeps being 0. And you can take the square root of a positive number, that's fine. You just can't take the square root of a negative number. So that's all that part means. So we have got a big simplification mission to do here. Let me write this all out. We have y to the 1/2 times the square root. No, it's the cube root. Oh, man. The cube root of 16x squared. Y to the 3/2 plus 8y squared. Okay. And then if we look at some of our answers, it looks like they took out stuff in some of them. They left everything underneath in one of them. Let's see what happens. This is going to be great. Okay. Let's factor everything we can inside the parentheses. We got some stuff that is factorable. So y to the 1/2 will stay here. Cube root of, both of these have an 8 in them. I'm going to take out an 8. Both of them have y. So I'm going to change 3/2 here to just 1.5 real quick. It's going to make this next part a little easier to understand. That's y to the 1.5. Okay, so they both have y's in them. We want to take out the largest y we can, which is going to be y to the 1.5. Yes. Okay. Y to the 1.5. So now what we have here, we still have 2x squared. And over here we still have y to the 1/2. Because we took out a 1.5 from this y, which means it's gone. And we took out y to the 1.5 from here, which means we still have 0.5 left up there. All right. All right, all right. We're having fun here. We're doing the Lord's work, I guess. Y to the 1.5, I'm going to turn that back into 3/2. We can do some cube rooting now. 8 is cube rootable. The cube root of 8 is 2. So I can take a 2 out front. So now we have 2 times y to the 1/2 and y to the 3/2. Let me think about this for a sec. Yes, we can do that. So I'm going to rewrite this cube root as parentheses all to the 1/3. Levi said this earlier, but it is annoying to have to keep converting between radicals and exponents. So this right here is now going to be one big to the 1/3 power, which is the same thing as taking the cube root of something. All right, it's got a little messy. I apologize. I didn't mean it like that. It's not what I wanted. It's not what I wanted. This is the last thing that I wanted, okay? We've taken the 8 out. We took the cube root of the 8. That's good. We're going to take y to the 3/2 to the 1/3 power. And if this is inside the parentheses and this is outside, that means you multiply the fractions together. The exponents get multiplied. So 3/2 times 1/3. This is going to be nice and friendly. 3's are going to cancel, leaving you with 1/2. So this was going to come out, and it's going to become y to the 1/2, which is going to make that part a lot cleaner in just a sec. So let's see what we still have left. We got rid of this. We got rid of this. So we still have 2x squared plus y to the 1/2. That taken to the 1/3 power. So here we can simplify y to the 1/2 times y to the 1/2. You add the exponents, you get 1. So this is 2y. Let's see how close we are. Oh yeah, we're pretty much right there. And then this whole thing is the cube root of this. You cannot separate these because there's addition between them. You can't take the cube root of both of these separately. All right, that's just like doing something like this. X plus 4 squared. Oh, you distribute the 2. We get x squared plus 16. Now, you'd have to FOIL in this situation. You're going to get x squared plus 8x plus 16. You didn't do that. If there's plus or minus, you cannot just distribute the exponent down to both of them separately. So there's nothing else we can do in this term right here. I'm so stressed from the SAT. It's okay. Repress, dissociate, you'll be fine. Cube root, if you look at the answers, they reinstated the cube root as opposed to just taking it to the 1/3 power. So this stuff is now going to be underneath y to the 1/2. Not Kuzi, you're going to be fine. You're going to be fine. Keep talking to us. Got it. Good. You're good. Excellent. All right, it is 7:30. Levi's tutoring. I'll be tutoring soon. It's a wonderful night for education for Levi and I. We love education. That's why we're doing this. That's why we do everything that we do. I breathe so that I can continue living, to continue educating. That's the logic that I go through every second. Should I keep breathing? Well, I want to keep educating. That's what I do. Good. Everyone, have a good night. Now, Kuzi, thank you for all the questions. Everyone is doing excellent. And just to remind you, we are nerdish.